Okay, hi there. I'm going to tell you about a more recent research trend where we apply tools concepts from computational neuroscience to mental illnesses, in this case schizophrenia. I'm going to tell you particularly about top-down computational neuroscience, where we take concepts from AI, machine learning, computer science, and we view what's going on inside the brain in those terms. Okay, so let's first, I've got a few papers here. These are sort of inspiration for this as well. And I've dropped a few more papers in throughout the slides that follow. Okay, so first perspective, reinforcement learning, really, really important thing. It's a kind of formalism that happens here. I'm not going to show you any maths, but what you have is an agent acting in an environment. They observe the environment, they perform actions, they have consequences, and then often these are, either have positive or negative consequences, and there's a reward associated with this, which is either positive or negative accordingly. And you want to learn how to sort of maximize the reward. That's just, living life well, essentially. And there are two sort of main paradigms of learning that you can do. One of them is called model-based, where you learn how your actions have consequences on the world and whether they are good or not. So you reason about the world, you plan accordingly to maximize the reward. And then there's model-free learning, where you sort of over time learn to associate rewards like with the actions and the stimuli, and you don't really think about what the world is doing and the consequences in that sort of explicit sense. It's very sort of habitual. And we observe this in nature. It also sort of works sort of artificially as well, but we have different learning systems in our brains because these two types of learning have different advantages and disadvantages in different situations. So yeah, the way you really need to think about this is model-free is very habitual. It's about instincts. You take the stimulus, you produce an action, and in model-based learning, you learn how the world works, you reason, you plan. It's very adaptive, and it's a lot quicker. Okay. So this is where it gets interesting. It's been a well-known fact for a while that dopamine is really important for model-free learning. It actually corresponds to something called a prediction error, or a temporal difference error, which kind of is the difference between how you predict the reward of an action is going to be against what actually happens. And so when we put people in these surprising environments and they're making decisions, you will see sort of spikes of dopamine when they were wrong about something. And this helps them learn how to behave. It's either to learn up a new behavior to increase the rewards or to avoid negative consequences. And so we've seen in the medication slides that so we treat schizophrenia using sort of dopamine altering medications. That's because dopamine is super important here. Usually the theory is there's a bit too much going on inside people with schizophrenia. And so, okay, we know that. We also know it's really important for reinforcement learning in model-free learning. Makes you think maybe there's a bit too much model-free learning happening in people with schizophrenia as well. And if you put people in a room, you make them do certain decisions, change the rewards about, and you compare people who are sort of have schizophrenia and people who don't, you can really see a difference here. And yes, it seems to be an increase in model-free learning. Very interesting. And there are a few ways you can interpret this as well. I mean, a few sort of consequences of this. So one of them, you would say we naturally have an appropriate amount of model-free learning. If there's more going on, you might start to connect stimuli with outcomes and positive and negativity, which aren't really connections out there in the world. And this, you can see, can sort of lead to delusional beliefs, and it can really sort of get exacerbated. And this is potentially a starting point for those kind of beliefs. Another one is not only does there seem to be more model-free learning, but having an excess of model-free learning sort of reduces and sort of dominates over the model-based learning. But model-based learning is really important, and you can see from this graphic down here, this graph, it is a lot quicker. And I would say in a modern world, we're forced to act really quickly, we're forced to learn things quickly. If you can't do that, that's just quite difficult in a fast-paced world. And so when you have struggles of learning stuff, in schizophrenia, this is partly why. And another symptom which is quite interesting is to do with the language. So you find when people with schizophrenia are talking, they can often get distracted by homophones and similar sounding words. And if you think about it, that is more of a surface level stimulus, surface level data, less about the meaning, about the world model. It's probably not surprising that this happens if you're relying on model-free learning more and getting distracted by it in that way. Okay, so that's a good starting point. It turns out it's maybe a little bit more complicated than that. If you do some more sophisticated experiments, you can find that the irrelevant stimuli, the neutral stimuli, or the neutral rewards, they are learned more, as just talked about, but actually sort of learning in general from positive rewards is reduced. And this, you can't really account for that with the simple increase in dopamine, increase in model-free learning model. It's too simplistic. However, it's a good starting point. And people are now looking into this, and they now think sort of these different layers of rewards according to the actions are sort of learned about in slightly different systems, sort of separately and coordinated by the dopamine signaling. And then there's some a disturbance in the levels here. So this is very interesting. Disturbances in the sort of coordination of these different systems. And so people are looking into this more, and to get this level of sort of specificity and really getting down to closer to neural circuits, we need to start doing experiments in in more animal models away from people, because we can use cutting edge neuroscience techniques like optogenetics and sort of neuron level sort of imaging and all that stuff. So this will really help us. And by doing this, we can improve, hopefully, the therapy available through some more sophisticated knowledge. Okay, let's have a look at a different perspective, if you allow me. This one's quite interesting. So now, let's think about where the hallucination's coming from in schizophrenia. So what we have here is a model of perception. It's called a hierarchical predictive model. It's also in this sort of Bayesianist tradition of thinking about the brain, where you have, see at the bottom here, sort of your external sensory inputs. These are the ones coming from your eyes or your ears and so on. They are sort of reduced to a more semantic inner representation in the brain. And in order to make sure you're representing the world in the right way, you've got to make sure it lines up to your sort of actual stimuli. So you kind of project it back down into the earlier layers of the perceptual system, and you take error comparisons, and this is how you learn to represent the world. Now, to make sure this behaves properly, you kind of need to impose some priors on your internal representation. And this is supposedly happening on multiple levels. We have loads of prior beliefs about what's happening in our environment, and this really feeds back onto our perception. And so in this sense, we're all sort of having hallucinations all the time, and we need this as well because our immediate sensory information is not sufficient to perceive a whole environment. Your actual, your phobia takes in very, very little information at each point, so we need to construct an environment to situate ourselves in. This is arguably a way that it's done, and so we really need accurate, well-constrained priors to predict your own environment well. And so we've already thought about how delusions arise in sort of the schizophrenic brain. If you've got that, if your perception is determined by what you're believing, you can now start to think as well, maybe this is where the hallucinations are coming from. They're coming from inside. You're not just somehow randomly hearing people talking about you. You believe people are talking about you, and then you hear it because of that belief. Really interesting inversion to what you might think. Yeah, this is taken from a really cool talk. By the way, it's on YouTube. You should go watch it. I think I've said enough about this, other than you can think about how, yes, you will get positive feedback loops as well, because you then hear it, and then you'll believe it even harder. This stuff really escalates. And I think one of the main things here is lots of feedback loops in schizophrenia between the delusions, and then things get really entrenched. Model-free learning takes a long time to get out of that because it's slow. It's slow to learn. It's slow to unlearn. Really, really deep into all these beliefs. Very tricky. But that's this. Okay. So yeah, just to summarize, we talked about a whole bunch of things to do with schizophrenia today. The symptoms how it develops, treatment options, diagnostics, how people recover, the history of how they've been treated in society, and so on, digital health applications, and also some perspectives from computational psychiatry. So yeah, thank you very much for listening. Open to any questions.
As I say, I mean, this is fantastic. You know,